Hello everyone. In this video lecture, we will study the how force on current carrying conductor is created in the lying in the magnetic field. So, suppose consider a magnet that is which consists of N and S pole. So, we know that the magnetic lines of fluxes is always flows from N to S. Consider a second case, the conductor which is carrying a current. In this case, suppose this is a 2D diagram. So conductor enters in this screen, means enters inside the screen, which denoted as a cross convention. So if we consider a right hand thumb rule, if we put the right hand thumb rule and put your thumb uh, in the direction of screen in this case, so we will see the magnetic lines of fluxes starts the clockwise direction. So these are two different things. So if we put this two condition, that is we put this current carrying conductor inside this magnetic field which is produced by the N and S pole. So consider a place that is surface above the conductor. So the magnetic lines of main magnetic lines of fluxes is starts from left to right, and in magnetic field created by the conductor above the conductor surface is also in the same direction. So these two fluxes adds together above the surface. But in down surface, that is below the conductor surface, this flux is from right to left. That is main magnetic field is left to right, and below the conductor surface that field created by the conductor is in opposite direction below the surface of conductor. So this weakens the magnetic field below the conductor surface. So magnetic field is like a rubber band, so it will stretch out and push the conductor in the downward direction. Same way as if we consider another condition, that is current is comes out of the conductor, that is in this case towards you. So the direction of if we find the direction of magnetic field by using a thumb rule, then the direction of magnetic field is in anti-clockwise direction. So the surface below the conductor is adding the magnetic field because it is clockwise direction, and below the conductor it adds the main magnetic field, and above the conductor surface it opposes the main magnetic field. So above the conductor surface the field is weakened. So the conductor is tried to move in upward direction. So these are the two conditions. That is, this is how the force on magnetic current carrying conductor is created. So this is theory related that how the force is created on current carrying conductor as in magnetic. So next is Fleming left hand rule. So direction of force, that is the direction of force which is created on the conductor can be determined by applying Fleming's left hand rule, which states that forefinger and middle finger of the left hand are stretched in such a way that they are at right angle. Right angles mean 90 degree to each other mutually. And forefinger towards the direction of magnetic field. Means forefinger indicates, that is in this case the magnetic fields always flow from N to S. So this forefinger indicates the direction of magnetic field. Middle finger towards the direction of current. Suppose this current is flowing from this direction, so in this case the magnetic field is in this direction, current is in this direction. So middle finger indicates the direction of current. If the these two values, that is magnetic direction of magnetic field and direction of current, if we know, then the thumb represent the force or acting on the conductor. Force acting on the conductor. So this is how we calculate or we know the direction of force is created in which direction. So basically, suppose in this diagram, see if current is flowing inside the screen in this case. So the magnet direction of magnetic field is from left to right. So forefinger is indicated, indicates the direction of magnetic field, and thumb, sorry, the middle finger, that is towards the screen. So the thumb indicates represent the direction of magnetic field that force is created on conductor which is in downward direction. So next, first machine is three-phase induction motor. So this is basically works on this is a basically AC motor, which is required AC supply. So three-phase induction motor is the most popular type of AC motor. So it requires three-phase AC supply. So more than 90% of mechanical power used in industry is provided by three-phase induction motor because of its simple and rugged constructions, good operating characteristics such as good speed regulation, good power factor, high efficiency and high starting torque, and little maintenance. So this is basically workhorse of industry. So construction of three-phase induction motor. So in construction there is a motor frame, outer motor frame. Next is stator, which is mounted or which is attached to this motor frame, which is a stationary part. Next is this is a shaft, and on the shaft there is a rotor is mounted on that shaft, which is a rotating one. Next is fans in order to cool down the machine, and end bell, that's it for packing, and wiring cover to feed the supply to the three-phase stator winding. So construction of three-phase induction motor. So essential features of three-phase induction motor are laminated stator core, which carrying polyphase winding. So in this case, three-phase winding. So three phases are supplied to the stator winding. Next one is laminated rotor core carrying either a cage or polyphase winding, similar to the stator winding. Shaft means in if we use a polyphase rotor, then that on that shaft we use mounted on the slip rings. Fourth one is shaft. Fifth one is frame to form stator housing and carry end covers to cover the entire stator winding and rotors. Bearings in order to fulfill smooth rotation. So we use a bearings, and last one is terminal box to take out or to supply the uh, electrical supply to the stator wind. So first is stator core. So stator is stationary part. So stator core is carrying alternating flux as supply is AC, alternating AC supply, alternating current supply. So flux is also alternating, which produces hysteresis and eddy current losses. So in order to reduce that these losses, we use stator core that is made up of high grade silicon steel alloy laminations in order to reduce hysteresis and current. So the laminations are slotted on the inner periphery and are insulated from each other by coating of varnish or oxide. So in this this is the stator laminations, and inside that this full version is this is rotor bar and this is the shaft, and in between these two there is a area. So inside inner periphery of the stator there is a slot to put the conductor inside of that slot. So insulated stator conductor are placed in these slots. So the stator conductors are connected in such a way that to form a three-phase winding, that is either in star or delta. Next is stator field winding. So on the stator pole, that stator core, we put a conductor in order to make a three-phase winding. So stator winding is usually three-phase winding, which is usually supplied from three-phase supply mains. So three-phase winding can be connected to either in star or delta depending upon the meter of starting use. So this is basically, suppose this brown is that is pole number 2 and pole number 5 is suppose R phase R connected. Next one is pole number 3 and 6 Y connected, and fourth pole number 4 and 1 is B connected. So the squirrel cage motors are usually started by star delta starters. Therefore, a stator is designed for delta connection. And the wound rotor motors are started by inserting resistance in rotor circuit. Therefore, stator winding can be connected in either star or delta. Next is rotor. So rotor is also built up of thin laminations of same material as the stator with slots around the core that is on its outer periphery carrying rotor conductors. So in this diagram, this is a rotor. So the slots are created on this outer periphery of the rotor. So there are two types of induction rotors. First one is squirrel cage rotor or simply cage rotor. The second one is phase wound or wound rotor or slip ring. So this is a squirrel cage rotor or simple cage rotor. So it consists of bars, that is copper and aluminum bars, and these bars are short circuited or closed entrance. So these are the slightly skewed, that is it is parallel to the shaft, but these are, suppose this is a shaft and these are the slightly tilted or skew by some angle in order to create uniform magnetic field and avoid the synchronism. Synchronism means the speed at which the three phase means if we put a supply, if we use the supply to the stator, three phase supply to the stator winding, it creates a magnetic field. That magnetic field rotates at a particular speed. That speed is we called as a synchronous speed. So in order to avoid that synchronous speed, means in order to avoid that this rotor is started rotating at that speed of magnetic field, we make it a slightly skew shape conductors. So in cage construction, copper, brass or aluminum are placed as the rotor conductors parallel to the shaft. So one uninsulated bar in each slot. So in each slots we put a uninsulated bar or so at each end of the rotor bar conductors are short circuited by heavy end rings of same material which is used in a rotor. So rotor conductors and their end rings form a cage that is complete closed circuit. So which was once commonly used for keeping squirrels. Hence its name as a squirrel cage rotor. The slots on the rotor are not always parallel to the motor shaft but are slightly skewed. Like in this diagram, this slightly skewed, tilted by some angle, not in parallel with this shaft. Because more uniform torque is produced, reduce magnetic locking of the stator and rotor. That is, during locking, the rotor and stator teeth attract each other due to magnetic action. So, in order to avoid that magnetic locking, if magnetic locking takes place, then the rotor and magnetic field is rotates at same speed, but we don't want that. So, we use a skew conductor. So rotor is not connected electrically to the supply but has a current induced in it by transformer action from the stator. So those induction motors which employ squirrel cage rotors are called squirrel cage induction motor. So in next lecture we will study the second type of rotor, that is phase wound or wound rotor slip ring motor. Thank you.